Ions are another important concept for this chapter, and an ion is just an atom or a group of atoms with a positive or a negative charge. And down there is a little picture, and you can see here how sodium chloride table salt is made. A sodium atom, all right? If you look on the periodic table, sodium is number 11. And we're going to see that sodium loves to lose an electron. And when that electron is kicked out, you went from 11 electrons. The neutral elements always have equal protons and electrons. It goes from a neutral atom to an ion with a positive charge. And the reason for the positive charge is that this thing lost an electron. It still has 11 protons. Remember, if you change the proton number, you change the actual type of atom it is. So it's still sodium, but now it has one less electron. So if you take 11 times plus 1, and add that to 10 times negative 1, it's like 11 minus 10, you're going to have a positive 1 charge. And we call that a sodium ion, or, as we're going to see in the next slide, a sodium cation. Cation is a positive charge. Now, electrons are pretty feisty, and they don't stay by themselves for very long. So if sodium's going to be losing an electron, that electron has to go somewhere. And we're going to see that chlorine likes having an extra electron. Now, chlorine is number 17 on the periodic table. So it has 17 protons. And even after it does something with the electron, it still has 17 protons. But you can also see then that chlorine goes from the neutral version, and remember, neutral means protons and electrons are equal. It goes from 17 electrons to 18 electrons. So if you do the same thing we did with sodium, now you have 17 times plus 1 plus 18 times negative 1. You've got negative 1 left over. And that's where that negative charge shows in. This would be a negative ion, or fancy term is an anion. And we're going to see that it likes to be negative 1. If you take away an electron, it makes a cation. And again, a cation has a positive charge, so sodium forms a cation. On the other hand, you've got to do something with those electrons. If you add an electron or electrons, you create an anion with a negative charge. So cation means positive charge, anion means negative charge. And I have to warn you in advance that I am kind of a cat person. We have right now 2 cats that are kind of fun. They have their own personalities and stuff. You do not have to like cats to do well in this class. However, here's a quick way to remember cations especially. Cations, remember, are positive, so they have more positive protons than electrons. Anions, on the other hand, have more negative electrons than positive protons, so they're negative. So, cats have pos. Cations are positive. So if you're a cat person and you're into that, this is kind of a fun way. That's a little chemistry cat meme, which floats around the internet quite a bit. It always cracks me up. I have several jokes and stuff running around that people have made with the chemistry cat. But anyway, that's neither here nor there. The important part here is that cations are positive, anions are negative. And I don't have a cool expression for that. Sorry, but if you think of one or you see one, let me know.
When a magnesium atom loses 2 electrons, it becomes a cation.
This is an example of a magnesium cation being made. So it's a positive magnesium ion. Now magnesium is number 12 on the periodic table. So neutral magnesium means 12 protons and 12 electrons. But we're going to see here in a little bit, magnesium loves to lose 2 of those electrons. So the positive 2 cation forms Mg2+. And this is very, very common. We will see in a little bit with magnesium.
Fluorine becomes an anion when it gains 1 electron.
Fluorine, with 9 protons and 9 electrons when it's neutral, loves to get 1 extra electron. And when it does, it becomes the fluorine anion, all right, the F minus 1. So an anion has more electrons than protons. So fluoride, which is what we're going to call it, or a fluorine anion, has 9 protons and 10 electrons. So again, you can lose just 1, you can lose more than 1 electron, or you can also gain 1 or gain more than 1. So the question becomes then, like, what are the charges of the different species on the periodic table? And that's a great question. So we're going to talk here, first of all, about the positive ions, the cations on the periodic table. Now, in this section, it's very helpful if you have a periodic table. And I encourage you to write notes on it because they'll be helpful later on. There are 2 types of metals on the periodic table. All of the metals will be positive, but some of the metals, we know what their charge is all the time. And so the charges that we know all the time are called fixed charge metals. And there's basically like 2 sections, all right? The 2 sections with these fixed charge metals are groups 1A and 2A. That's like one big section. And then there's also what I'm going to call the stairs, and I'll talk about that in a little bit. Most of the time, at least for groups 1A and 2A, the charge equals the group number. So if you've ever been curious about sodium and what it can do, all right, sodium is a group 1A metal. It's number 11 on the periodic table, but the important part is that it's group 1A. Remember, the periodic table we're using in chemistry has a 1A on the left and 2A right next to it. 3A begins over under boron, number 5. It's also sometimes known as group 13, etc., etc. So magnesium is in group 2A. That's why magnesium likes to be positive 2. And sodium in group 1A, like I said, likes to be positive 1. But everything in those groups is going to be the same. So above sodium is lithium. Lithium, a group 1A metal, positive 1. And below sodium, potassium, K. Potassium also likes to be positive 1. Same thing with group 2A. Magnesium, right above it, is beryllium. Beryllium likes to be positive 2. Right below magnesium is calcium. Calcium likes to be plus 2. So anything in group 1A is going to be positive 1, and anything in group 2A is going to be positive 2. Hydrogen is usually listed in group 1A, and often hydrogen is plus 1. We're going to see that hydrogen's kind of funky sometimes. It does more than one kind of thing. But for this argument, and more often than not, hydrogen is plus 1 too. Now, on the stairs, which I'm going to show here in a little bit, you have to know which of the stairs you're on. But you can probably see that aluminum, gallium, and indium are all plus 3. Zinc and cadmium are both positive 2, and silver is plus 1. So these metals, you always know their charge, and that's really nice. There's no exceptions. So sodium's not going to be plus 2, magnesium's not going to be plus 1, aluminum won't be plus 2, etc., etc. Predictable charges is what fixed charge means. All the other metals, though, on the periodic table, and there's a lot of them, all right? We only talked about groups 1A, groups 2A, and those 6 elements in the stairs. All the other metals, which is all the transition metals, it's all the lanthanides, it's all the actinides, and there's actually quite a few metals under the nonmetals, if you draw in the metalloid line. All of those are what they call variable charge metals, and it's really difficult to know what their charge is going to be. You could ask me what the charge is on some random iron atom, and I wouldn't know. You have to have some kind of way to convey the information to other chemists. So scientists use a Roman number to represent the charge. So if you had an iron plus 2, for example, iron's a transition metal, so it's an unknown, unlike the last ones, you would write it as iron Roman numeral 2 ion. And that's important because there's also a very common iron plus 3. That would be iron Roman numeral 3 ion. And you can see there's a vanadium 3 plus, which would be vanadium 3, etc., etc. Now notice that the ones under the fixed charge metals didn't have the Roman numeral. The Roman numeral is only for the metals that are outside of groups 1A, groups 2A, and the stairs. But if you have a metal in there, you have to tell the other chemists what charge is on the metal, because there are different kinds of charge. If you've seen references to ferrous and ferric compounds, which are iron, or maybe cuprous and cupric, or chromis and chromic, or something like that, that's an old way of representing different charges. But I do not want you using those in my class. Ferrous and ferric and cuprous and cupric and all those things are really lame, in my opinion. And I can talk about this with you sometime if you're curious away from here. But for right now, use the Roman numerals. And again, use Roman numerals anytime you have a metal which is not in group 1A, group 2A, or the stairs. Those fixed charge metals are predictable. The variable charge metals are not predictable. So you need to tell the other chemists what's going on. Let's say that you had a barium and you wanted to know exactly what the charge was on it. That's a really good question. Now, barium on the periodic table has number 56. Z is the atomic number. So you can look at number 56 and tell what it is. So the question, you have a barium -2, barium -1, +1, +2, and the Ba2, which is a diatomic barium. Now, first of all, if you're talking about barium, all right, it's a metal. It's to the left of the metalloid line. So we know that barium is going to be positive, all right? It's not going to be negative. We're going to see the nonmetals are negative. But most importantly, barium is a group 2A metal. So that means it's a fixed charge metal. And we always know what their charges are. So because it's in group 2A, which is one of the groups up here that we know, that means that barium's going to be a +2. And barium, anything, barium chloride, barium sulfate, barium fluoride, whatever, all of those are barium +2. Barium does not really like being +1. It certainly won't be a negative charge, and I've never heard about a diatomic barium, Ba2. The diatomics are the have no fear of ice clear brew, and those are important, but barium is certainly not one of them. The stairs are really interesting. It's a group of 6 elements that have very fixed charges. They're almost always this way. And you can see if you use your imagination, it is like a stairway. Silver is Ag, that's the first step, and it's a +1 metal. Then you take a step up, and the second step, which has 2 steps in it, if you will, is a zinc 2+ and a cadmium 2+. So the elements in the second step are +2. Then you take one more step to the third step, and you've got aluminum, gallium, indium, and those are all +3. So these 6 elements are considered fixed charge metals, just like groups 1A and 2A. Groups 1A are +1, groups 2A are +2, and these are either +1, +2, or +3. Group 3, all right, has boron above aluminum, and below indium, you have thallium, Tl, and those are not fixed charge. Those are a little bit more random. But at least for these 6, you can say that, yep, you always know their charge and stuff. So just kind of realize groups 1A and group 2A and these 6 stairs metals have fixed charges, and you always know what they're going to be. The nonmetals are really important to chemists, and nonmetals have fixed charges, but fixed nonmetal negative charges, and that's going to be really important. So the nonmetals, if you look at these are some of the representatives from that upper right corner, and the way to figure out what the negative charge is you take the group number and you subtract 8. All right, so this is using the A version of the periodic table. So that means fluorine is in group 7, oxygen's in group 6, etc., etc. So to figure out the charge, fluorine is in group 7. 7 minus 8 means that F-1 is the common ion, the anion that you see from fluorine when it gains electrons. But notice here we changed the name, and this is real common in chemistry. The negative ion almost almost always gets an IDE ending. So fluorine becomes fluoride, and chlorine becomes chloride. You can see that oxygen in group 6, 6 minus 8, -2. So oxide is oxygen with a -2. Going one to the left, nitride comes from nitrogen, and that's 5, group 5 minus 8, -3. If you've heard about like carbide drills, carbide is carbon, group 4, 4 minus 8, it's a -4 carbon. Not as common, but still kind of interesting. Also, if you hear that IDE ending, you know you've got something negative, and that's going to be important to us later on. So on the periodic table, there's fixed charge metals, group 1A, group 2A, and the stairs. There's variable charge metals, which is basically all the metals outside of the 1A, 2A, and stairs. And then you've got the non-metals. Group number -8 is how you figure out their name. But do give the non-metals an IDE ending. Let's say we wanted to figure out what the probable charge is on a phosphide ion. All right. Well, phosphide has an IDE, so it's negative. And phosphide, you might be able to imagine, comes from one of the elements, phosphorus. Phosphorus is under nitrogen, and both of those are in group 5. So the charge on the phosphide will take the group number 5 minus 8. Phosphide is going to be P -3. If you hear phosphide, that means it's a phosphorus with 3 extra electrons. Phosphide has a -3 charge. Kind of overview of what's going on. There are the fixed charge metals, 1A, 2A, and the stairs. Everything in group 1A is +1, everything in group 2A is +2, and the stairs are +1, +2, or +3. And they're all positively charged, all right? There's no negatives. And the magnitude most of the time equals the group number. That's not necessarily the case for silver, zinc, and cadmium, but the other ones it works pretty well. Now, groups 5A, 6A, and 7A are the nonmetals, and those are always going to be negative, and you take the group number -8. Now, that would also include, of course, carbon is carbide, but most of the time this works pretty well. So they're fixed charge nonmetals, and that's going to be important to us. All the other metals, though, are variable charge metals, and they're difficult to predict. So if you ask me, for example, what's the charge on a titanium atom? All right, even me with my PhD, I couldn't tell you, all right? I can tell you more likely possibilities than others, but I can't tell you definitively. Like if you ask me sodium's always +1, all right? Unless you're in a lab or a black hole or next to the sun or something, but sodium is +1. Titanium, though, titanium's kind of all over the place, so that one's harder to tell. So we know that the variable charge metals will be positive, but we'll use a Roman numeral then to represent the charge on the metal.